Good morning, everybody, and good morning to those online. Thank you for joining the beginning of the buildingSMART International Awards Programme for 2023. This, of course, is one of the highlights of the buildingSMART Summit and, of course, the event calendar as we get to recognise the openBIM projects that get submitted throughout the year. Of course, this wouldn't be possible without everybody here in the room, and of course there are lots of things that we would like to recognise and acknowledge as we get started. But firstly, I'd like to acknowledge Susan Keendyside, who has been the programme leader since its inception in 2016, and I'd just like to let you know that Susan has taken a step back for the moment from the awards programme for personal reasons, but we do hope she will be available in the near future. So I think this is, as we can agree, a very proud moment for projects and for the countries. Of course, we have 31 chapters around the world, and this is a very important moment for the international community to understand, to learn, and to share experiences from their projects. Of course, being here as a finalist is already a great achievement, so please congratulate yourself as category finalists. That even getting to this point is a very difficult process, and we congratulate you on that. The process will be, we have an elite juror sitting there in the middle of the room, and they will be watching intently, and they will be judging each project, and we will ask them after the projects are finished, are there any questions per category. They will then ask you questions based on your presentation, and they will then deliberate and decide on a winner for each category, of which that will be unknown until the gala dinner tonight. I do want to then wish you all the very best of luck, and congratulations once again for getting this far, but I do wish you all the best of luck for your projects. Of course, it's also worth mentioning that Dan Little has played a huge role in the awards programme as well, and I thought it might be nice for him to share some of the facts and figures from the awards programme and a few other bits and pieces.
Yeah, thank you, Aidan. So I'll be very quick, but just a recap of the program. We had 137 submissions started in this year's program. Of those, 69 passed through the triage stage. We had a technical triage who helped us with that process. And in the 9 categories where we have finalists that you'll hear from today, there are 22 submissions. So we've got a lot to get through today. Very looking forward to it. I've been involved in the program from the start, so quite familiar with a lot of the people that will be presenting here today, and I know a lot of time and effort has gone in from that side of things, and of course also from the international jury. Great to see everyone here today. Looking forward to your presentations. If I can please remind each submission, each presenter or presenters to keep strictly to their time limit. There is a prompt up the front here. We do have a lot to get to, and to keep it fair, if you can please stick to the 15 minutes, that would be much appreciated. We will then go off with the elite jury, make our final decisions, which will be kept strictly confidential until the dinner this evening, and look forward to seeing you all there. A reminder that it is also available, it is also being streamed, and everyone should have been sent that link, so please share that with your colleagues, people that can't be here with us, and look forward to seeing you at the gala dinner. That's it from me. I'm going to quickly hand over to Claire, who has one last official introduction to the session, and then we'll get things underway. Thank you.
Hello and welcome. In this session, finalists from the Construction for Infrastructure, Construction for Buildings and Handover categories will present their entries. The session is scheduled to last 2 hours, including time for questions and answers at the end of each category, as Dan said. And it's being recorded and will be made available in the replay section of the event as soon as possible. Before I hand over to the speakers, I would like to remind you that this is a hybrid event. For online attendees, your microphones will be muted for the duration of the session. If you wish to make a comment, please use the chat box in the control panel or post questions there as well. For the attendees here in the room, please keep background noise to a minimum, and if you wish to make a comment or ask a question at the end of each category, please raise your hand and we'll bring a microphone to you. I'd like to bring your attention quickly to the antitrust code of conduct on the screen. Is it? It's on the first presentation, sorry. On the screen now. So as mentioned, the first category is construction for infrastructure. And now I'd like to hand over to our first presenter from the China Academy of Railway Sciences.
First of all, I will introduce this project. The total investment of project is $836 million US. The total construction area is 512,000 square meters. The total size of station is 11 platform and 20 lines. The building height is 16 meters. 5 floors above ground and 4 floors underground. The project is organized and managed according to ISO 19650 standard. China Academy of Railway Sciences is general consultant of BIM management. In the entire project process, information coordination, information requirements, and information exchange are required between the participating teams of project. The appointing party has determined the different information requirements in the contract according to the ISO 19650 standard. In response to the information requirement, the BEP was compared to ensure the correctness and the integrity of the BIM model and the data in the whole life cycle. The responsibility metrics and workflow are further clarified. A project level parameterization standard have been developed based on national and industry standard. It is mainly divided into 3 aspects: modeling standard, data standard, and coding standard. The BIM modeling standard defines the naming, project base points, and attributes of model or files for various disciplines. At the same time, it also clarified the component categories of each profession. The BIM data standard specifies family parameters based on information requirements. In the process of establishing the project family database, all the family components used are ended with current posting identity attribute, position attribute, technical attribute, operation and maintenance information. The BIM coding standard defines the relevant data interface standards according to the equipment assets coding of the operation platform. Converts PIM to AIM through data mapping. According to the information application requirements of design and construction stage, CDE is established and the data is integrated with the railway project management platform of the appointed party. During CDE, focus on the solving the problem of collaboration between designs. Participants are assigned to different professional groups and can upload model files and documents to sharing group with the approval of group leader. Design assume are checked through CD integrated BCF capabilities and calibrative workflow. The CD required information such as viewpoint, location of the design problem and the problem description. Through the 3 rounds of the model review, a total of 475 model problems are found in this project. After approval by the relevant parts, the model files and the documents will be released and shared to the constructions. CDs through the railway project management of data interface. The application of the ISO 1960-50 standard has greatly enhanced the communication between the parties involved. A clear division of the responsibility plays an important role in saving labor cost and communicator cost. Based on the concept of the openBIM, the management team established a CD using ISO 1960-50, worked collaboratively through BCF, combined the openBIM model with 3D laser scan data, using the COBIN standard to achieve data transformation from the construction phase to the operational phase, and also developed RFID and QR application. openBIM used. This is the software ecosystem map, which can be divided into 4 stages: design, procure, assemble, and operate. Through the application of openBIM, a collaborative work ecosystem is built, which provides a solution for complex design interface management of this project. In the design phase, Tecklenburg, Revit, and Rhino software are mainly used. Interaction between Tecklenburg and the Revit can be achieved through the FC format. Since Rhino doesn't support FC, geometric parameter extraction is assigned by XML. Once using Rhino for decoration design, it is necessary to extract the coordinate and radius of the center point of the grid ball node, and the radius and coordinates of the start point and the end point of the center lines of the bar. Then Grasshopper and Dynamo are used to read XML files. To completely model reconstructions in Rhino and Revit to ensure the edible model. For the construction play of rotating lift of large span irregular steel roof, the technical parameter of the rotating lift process are determined by important the geometry shape, materials properties, cross-section information, and the load of the Tecklenburg model into meta simulation. At the same time, the Tecklenburg model was spotted into network. in FC format for dynamic collision detection during the entire rotation process with the left frame. Reduce the assembly operation from 12 meters to 3.3 meters and save 520 tons of steel support. In the factory presence of the stage, the virtual pre-assembly technology used to fit the 3D text model obtained by scanning and the FC format reference model driven by Tecklenburg. Simulations the physical pre-assembly presence of the component and realize the science detect of single components. By importing the point cloud into network in STEP format from 3D laser scanning technology. Finally, Dynamo will patch write the calculated deviation of the XYZ of the spherical nodes into family parameters for achieving as a completely model. Presence information is collected using RFID chips and QR code. In the operation stage, QB standard is adapted to transforming the project information model. With the FC model as data carry into ascent information model. Integrated with BMS intelligent operating platform. Intelligent with the BMS intelligent operation. It is also connected to the Hangzhou City Brain CIM platform. Sustainability. The appointing party has clearly defined the overall construction requirements for the implementation of the Green Railway in contract. Optimization of building energy saving performance through simulation. The intermediate reverse preparation time is reduced from 10 seconds in the orange design to 5 to 6 seconds. Cobbing is used to establish the roof photovoltaic operation. Through the design operation, the entire life cycle of this project can achieve the carbon reduce of around 118,000 tons per units areas. It has obtained the 3-star green build design logo. Application benefit. First, it provide technical support for the delivery of BIM model in the whole life cycle of this project. Second, it provides the database for the assembly construction of the project and brings significant benefit for the sustainability of the whole life cycle of the project. Third, the integrated application of the deviation and analysis data extractions. The adoption of the openBIM has saved $6.34 million US. inclusion, openBIM is not merely a standard or format. It infuses BIM world with show. Thank you.
Thank you. And the second finalist in the construction for infrastructure category is China Communications Construction Company.
Okay, good morning, ladies and gentlemen. I'm Aaron, I'm from CCCC, and today I would like to share our project with you, which is the Hong Kong Integrated Waste Management Facilities Phase 1, the IWMF projects. In the following, I will separate my presentation into 3 parts. The first one, key project information. Second, key openBIM information. And the last one is the key outcome. And for the first part, I've separated into 4 topics, project background, project stakeholders, project timeline, and the constraints and challenges. Our project is a design and build and operate projects, which the contract sum is over $4 billion US. This is the first waste to energy facilities in Hong Kong. There are over 10 buildings on a 16 hectares artificial island. The design capacity of the facilities is 3,000 tons per day, and it can reduce 90% of the waste volume. And it can generate electricity for 100,000 households at the same time. And you can see this is our project stakeholder. On the left, we have our clients, which is the Hong Kong Environmental Protection Department, and our supervising officer, AECOM, and we are the main contractor, CCCC. And in the middle side, you can see our key partners, including our designers and our BIM specialists. And on the right-hand side, this is our key subcontractor working in our project. You can see we have a very lots of company involving in this project. And this, our project started in late 2017, and we have carried out 1 year for designs. And starting from 2019, 2020, 2021, we do our reclamation works. And starting from 2022, we start the building works after the reclamation is complete, and we will complete all the works by 2025, and then we will start our 15 years operation period. In our project, we have 4 major constraints and challenges. The first one is a tight program. We have only 18 months to complete all the design and construction works, including reclamation and all the building works. Second, remote offshore location. You can see on the map, our construction site is located far from the city. It's an island. There are no land access to the site. Third one, we have international stakeholders, because we have mentioned we have lots of companies involved. Some of them is from mainland China, some of them from Singapore, some of them from Hong Kong, some of them from Belgium. There are even more from other places. So it is very difficult for all our team members to collaborate to each other. And the last one, there are lots of, there's 140 companies in this project. It's very difficult to manage more than 100 companies at the same time. Therefore, openBIM is introduced to our projects. And okay, for the next part is the key openBIM information. I'll pass the time to Simon, which is the BIM manager in this project.
Thank you, Aaron. I would say, first of all, in the last couple of days, we've learned a new phrase, which I think fits in neatly. I'll try my best, hop et verkula. So following from China Railways, done a fantastic job with some really interesting stuff. So I hope we can not look too bad in comparison to them. So first of all, execution planning. So something I would point out is our project has been running since 2017. So as Aaron mentioned, my name's Simon. I'm the BIM manager on behalf of the joint venture. The joint venture, which is Keppel Sager's, the waste to energy experts, and the Hong Kong subsidiary Jinhua Engineering, who is a subsidiary of China Harbour, who is owned by CCCC. So that's how we all fit together. So I would point out that in 2017, when the project started, there was no ISO 19650, although it was coming. There was no BIM mandate in Hong Kong, although that came in 2018. So our project was exempt because it predated that. And also there was no IFC4. So we didn't have any of them to play with to begin with. So what we did is we were obliged also to use certain specifications and standards which we were not familiar with. For example, I'll try and say this one. It's a good Kraftwerk Kennzeichen, well, we just say KKS, it's easier, but Omniclass as well we were using. And in terms of the setup of the project, as I say, initially we didn't have the benefits that you would associate with ISO 19650, but the project was set up following PAS 1192, with the intention fully of transitioning to ISO 19650 when it came into play. So that was part of our role, that's what we did, and I'm proud to say that the project did achieve ISO 19650 accreditation, as did our client. So the CDE, as Aaron has mentioned, we had people around the world. We had Belgium, we had mainland China, Hong Kong, Singapore, and the CDE was crucial to that for the data flow. We'll move on. I think I need to be quicker, possibly. Okay, so I'm just going to quickly skip here and say this is something I really want to talk a bit more about. So we've got over 300 models, and the federated model that we use every week for our weekly progress meetings is over 2.5 gig, and it's grown as the project has grown. So it's getting quite hard to manage. And something I'll point out is the hierarchy. We have a hierarchy which all of the logical packages that the project is set into sit in the hierarchy, and the hierarchy basically is aligned with the phase of the project. So hierarchy 1 is design, hierarchy 2 is plant and process, which is critical to the entire procedure, but this is off-site manufactured. And then hierarchy 3 is for construction, and there's meant to be a transition from hierarchy 1 to hierarchy 3. And we also have a lot of software to play with, so interoperability is key, and this is quite a major challenge for us. So this is the other thing. So because Hong Kong, of course, before you start, you need to build the land to build on. So it's marine reclamation. So there's another additional challenge. As Aaron also mentioned, it's an island. So you have to build the island before you start. There's 16 hectares. And something that's worth pointing out here is the use of software. For example, Robot was used for the caisson design to find and ensure that the center of gravity is known. The importance of it not tipping up whilst you're trying to sink the thing, very important. And this is the federated model. So this is what we use every week. And what you get here is over here, there's a color system that we use to try to make it easier for all stakeholders to know who's responsible for what. It makes it easier as a visual thing to help us. Sorry, I'll just move on here. And then what we get is we get monthly reports that we have to put together. We get monthly reports from all the different stakeholders, and it's one of my jobs is to collate the monthly reports, put them together, report that to the SO, so the supervising officer, who has to check the work. So I have to present to them every month and show them progress, and this is where we get our information from. So one of the things that I think is worth mentioning is the fact that we try to be as open as possible. So all of the reports, everything that we do, is shared on BIM 360, and it's available to all parties. So anyone on the project who's in the project can see any of this stuff, any of the status, and they can also importantly see what other people are saying about them. So if you have one party who is saying, we are delayed because party X was slow giving us information, they can see that. So it helps keep people honest, I find. I think it's helpful. And then finally, what we have is this is the progress all the way through. So eventually, and this is the most important part, is this bit at the end, operations. The key to the whole thing is it's design, build, and operate. So what we need to do is hand over an asset, and that asset has to be managed. We have to hit a CMMS. The CMMS, they're chosen, it requires IFCs. We have to somehow manage to get data, IFCs, into a CMMS, which at the beginning of the project, we didn't even know. It hadn't been procured. We didn't know what we were dealing with. So that has developed along with the project, along with a lot of these things. And I think now it's your turn to speak. So thank you.
Thank you for Simon. And now we go to the last part, which is the key outcome in the project. We have 3 major key outcomes in this project in construction, which is the DCM design and construction, caisson design installation, and the MIC design and installation. First one, DCM design and construction. DCM means deep cement mixing. Is an advanced ground improvement technology we use for reclamations. Why we use DCM? Because dredging is not allowed in this project due to environmental considerations. And the DCM design is highly relies on the geological data. And where's the data come from? It comes from 3D scanning and borehole analysis. We put all the data in the models, and during the construction, we have more and more data, and we update our model regularly, and it helps to ensure our design is aligned with the actual site conditions and being optimized. Otherwise, we may have some additional remedial works to be taken, which will have time and cost implication to the project. Okay, second, this is the caisson design and the installation. Our seawall in this project is a caisson type seawall. The caisson is precast in mainland China and will deliver to the site by floating. During the design stage, we have carried out 3D structural analysis in robots. Simon just mentioned we will check about the center of gravity and the floating stability during the design stage. And you can see there's lots of works we have to carry out outside Hong Kong, including the physical model test, including the prefabrication. Those carried out in mainland China. Because we are based in Hong Kong, we cannot talk to them face to face. Therefore, the models plays very important roles. We can have a 3D coordination with them to ensure what they have done is what we designed. And before the caisson delivery from mainland to Hong Kong, we will do a 3D analysis. You can see that when the 3D seabed scanning, because the seabed condition is keep changing due to the weather or other issue. For example, there will be heaving after the construction of the DCM. And in this 3D analysis, we can figure out whether there's additional dredging or filling works is required before the delivery of the caisson. And you can see there's the actual delivery of the caisson from mainland to our sites. Okay, this is the MIC, design and installation. MIC means modular integrated construction. And in this project, because we have mentioned many times, this is waste to energy facilities. There's lots of processing equipment in our process building. To speed up the construction process, we adopt MIC, and we have divided our boiler to 12 single units. Each of the units are 60 to 7 meters high, 6,000 tons. The units was assembled in mainland China during our reclamation, and this allowed for time saving for 15 months. To make this process to happen, our model has to be fully well coordinated before the prefabrication. We have resolved all the clashes before the prefabrication, and we have do a 4D simulation before the delivery to plan the delivery routes and to assess the potential risk during the delivery. And you can see on the bottom left, this actual site photo taken early this year. Our first boiler units was transferred to our sites. And we will continue all the construction works and complete the project by 2025. And this is all our parties working in our projects. We thank you for all their works in this project. They've done wonderful works with us. Therefore, we thank you for their support. If you want to know more about the project, you can also contact with them. And also, that's, I think, is what I want to share today. Thank you for everyone listening.
Thank you.
Okay, thank you for both the presentations there. We're going to have a quick Q&A session now, so if you could please rejoin me on the stage. Okay, so I'm going to open the floor to the jury who are in the middle of the room here. Peter, would you like to go first?
Yes, yes, I have a question regarding the West Railway Station. In your presentation, you mentioned that you used COBie in the conversion from the project information model to the asset information model. Why?
Okay, so there's two points. One point is because there's so many softwares used in this project in construction stage and operation stage. So we would like to use COBie to standardize the standards to the information delivery. That's the first one. And the second one is from the aspect of customers and the view of the operation parties. We think the COBie is a better way to deliver information.
Okay, thank you. Casey or Sonia, do you have a question for the other project?
Hello. Yes, I also have question for the first team, and my first question is related to the who and when define openBIM standards for data exchange, if these standards are defined from the investor, or you as a contractor can use openBIM standards which you are using in your usual way of creating and using BIM in your own company.
So maybe 5 years ago, the Chinese government realized the importance of openBIM. So because this station is guided by the government, so government told the every parties of this project to use openBIM, and we really realized the value of openBIM in this project because it saves a lot of money and also give us a better way to imagine how this project will be established. I hope it answers your question.
Yes, and if investor define openBIM standards, do you have as a contractor some problems when using these standards, or you have to change something and propose some changes in using these standards, or everything which was defined by the investor was working well on the project?
So in this project, we really found the problem of the IFC to support this project because it does has some problem to convert the IFC model from design stage to construction stage, and so we used another software called the Rhino to convert IFC to other format via the point XML, and we also hope that the Rhino can support IFC soonly, and so that we can use a better IFC, and for this year's we also developed the IFC rail for this project.
Okay, thank you. So moving on to the next project, Casey.
Yeah, thanks, Dan. Congratulations to both projects for reaching this far. Well done. My question is for the waste to energy plant project. Is there anything you've learned through the project that would better enable you to use IFC and open data throughout the operational phase? And I'll let you answer that one first before I add a second part.
Yes, many things actually, and because as we kind of mentioned or alluded to in the presentation, we've grown with the project because the project started, it kind of predated certain standards, and if we could do things differently by starting again now, we would set things up quite differently. But at the time, we didn't really have a choice in terms of, for example, vendors, how we did things. We were quite reduced in terms of choice. I mean, something I'd like to experiment with, for example, is the use of open source, like using Blender BIM. Would be very nice. I understand there is a workflow that we could maybe, we still maybe will try and use that, because we have this need to go from where we are now into the major target is the CMMS. And if we could do things differently, I would know the target before we start. So they would have Maximo or whatever, they would choose, and the client would be a little more helpful, shall we say, in defining what they want. Because we've had to learn as we've gone along, and it hasn't made it easy. So yeah, we have learned, and we would do things differently if we could.
Okay, so you've kind of answered my part 2, which would be if the client was slightly more mature through this process, would it have benefited you if they understood
yes.
cases for?
I'd like to think they've learned too. I hope as we've gone along, because yeah, we've kind of learned together.
Thank you, Peter. Question for this project, or
I have a quick question. What was the main benefit for you of having the seawall in IFC?
For me personally, there was no benefit. I have to say, as the BIM manager, it didn't help me whatsoever. What my client wanted to do, they were looking to work with volumes. They were really interested in concrete volumes. And getting the information from, it was, the model itself, the authoring model was Civil 3D and also Revit. And getting the information into a shape, knocking it into shape where they could actually get meaningful data and calculating concrete volumes. We tried it many times using the proprietary software, and it kept missing things. It was quite difficult. So getting it into a single format is one way which is quite helpful, actually. Because it was a challenge, I have to say. It was very imperfect, and I don't know how much it helped them in reality, but it was, yes, that was one use.
I can see from the clock we're just about at time now, so I think we'll call it a day there unless there's a very burning, very quick question. No, okay, I think, yeah, 20 seconds left. I think we'll wrap up there. Thank you very much to both projects here for your presentations, and we will ask you to now vacate the stage, and we'll move on to the next category, and best of luck. See you later on.
Thank you.
So I'll hand over to Claire to introduce the next category now.
Thank you, Dan. The next category is construction for buildings, and our first finalist is from ZS Consulting.
Sorry, guys, I'm being a little bit too over the moon being Denmark. No, Norway, sorry. Alrighty, ladies and gentlemen, thank you for gracing me today with your presence today. Yeah, imagine this session as a treasure hunt with me, because we're gonna explore some of the benefits of practicing openBIM to the existing building to see how it could imbue the vitality with less effort. All right, and now let's go on a little trip to Hong Kong. Buckle up.
Hong Kong is currently experiencing a surge in new building construction, but many older buildings also need revitalization. To achieve urban sustainability, it is essential to adopt innovative technologies and openBIM method to revitalize these older buildings. The South China Hotel is one of them. This project is unique due to the considerable preservation of the existing building structure. It is the first hotel reconstruction project to adopt a comprehensive openBIM workflow in Hong Kong. In the design phase, we utilize 3D scanning data to create a digital twin, allowing us to proactively identify and mitigate risk and hazards before construction. The implementation of reality capture also aided in the efficient cloud-to-model comparison, managing GIS data and reflecting them in 3D from formats like GeoJSON and OSM are the cornerstones of our successful logistic planning and quality management. We were able to excel in automated drawing, producing, and syncing processes with the help of in-house API T-Time. This innovative tool also approves the multiplication and exchanges of BCF files between Revit and Trimble Connect with one click. Our team leverages Trimble Connect as a collaborative platform that enables us to work together seamlessly, irrespective of location and time. By relying on BCF as our medium and combining with GameTrack, our project team has effectively addressed and resolved over 500 BCFs. We are glad to include OpenSpace and HoloLens in the construction phase, which has helped us overcome spatial constraints caused by the pandemic, making issue tracking and coordination easy as a breeze. Urban sustainability and climate change resilience do not necessitate the endless loop of demolition and rebuilding. The renovation activity could improve the sustainability and circularity of the existing buildings. This project is a good starting point to actualize the circular building through openBIM and OpenGIS integration.
All right, it's a quick overview of the project and some of the project intention also mentioned. So as you can see from the figure, the South China Hotel is located in the heart of the North Point district in Hong Kong, and with the bustling business main road, the Java Road, as well as the busy Victoria Harbour on the corner. So thinking about reconstructing isn't the most optimal environmentally conscious choice, but retrofitting poses better benefits to the environment of the surroundings. And as the main contractor, we're working closely with the our design and system building design and system design teams to plan out the holistic openBIM workflows and ensuring the renovation project is completely promptly and left with minimal negative environmental impact on the surroundings. So just a side note, according to the building department from Hong Kong, over 50,000 buildings in Hong Kong, 1/3 of them are older than the years of 50. And most of them are the residential buildings, and they are the big emitter in Hong Kong, especially accounts for 2/3 of the carbon emission. So you see the urban decay and the environmental combat is not the only war that Hong Kong facing. So with that in mind, we're thinking to adopt the full length of the openBIM workflows and frameworks to ensure the interoperability as well as the sustainability of the project. We thoughtfully chosen the IFC and BCF schemas to attain interoperability throughout the project, making, I need to click a little bit more, and making informations and data shareable and commentable using the OpenCDE's permitted fluent cooperation among the project participants. And with our information delivery system and also the help of OpenCDEs, our information could be delivered and communicated in a flexible way. And our team are encouraged to work differently, none of that rigid type of way of work when collaborating on the project. Also, our thoughtfully chosen in the openBIM framework as well as the software, ensuring the sustainability not only about this data but also the actual construction work. And this huge circle with curves passing around just to demonstrate how we communicate the open data back and forth from different proprietary applications in the 3 different stages of the construction. And we're making sure that 90% of the data were open format and are interoperable to secure the integrity and data accuracy. So here, just want to quick mention that our company also developed a plugin to help us enhance the openBIM experiences in the project. And we also receive a little prize locally. The upcoming slides, I will talk about a little bit more on how we integrate our tea time into the actual workflow. Before I actually dig into what technology we've been using, I just want to highlight some of the project highlights through using the openBIM technology and the methodologies. So with all these open data formats, we're able to maintain 90% of the existing building structures, especially for the building openings when we're doing the ENM rerouting. And with the buildingSMART validation system, we're able to validate our conformity of any given data from our open CDEs. For example, we have over 30,000 IFC properties and 40,000 of IFC geometry that will conform to the international standards, as well as we'll also issue and resolve the over 500 BCF before the actual construction work. It's just an old cliche on the core values. And now let's dig into how we actually using this technology to help us achieve the sustainability and interoperability. So this project rely heavily on the exchanging of IC models and the communication of the BCF files. These two open data formats are the foundation of reciprocating and communicating among the project teams. And we're moving from using just archive floor plans and site photos to relying heavily on the scanning data to help us to reform the actual site condition in a better and faster way. The set of the point cloud data could also push forward into the next stage for analysis, such as dealing with the relationship between the site and the surrounding neighborhoods. We also see some benefits from the point cloud data when the Notre Dame de Paris caught the large fire in 2019. Billions of points became the savior for the from 2015 became the savior for the Notre Dame Paris, helped to reconstruct the roof. So similarly goes with Hong Kong. Hong Kong has a lot of historical buildings. Those are the collective memories, not only for the residents but also for the cities. So scanning data here could act more than just a useful tool when doing the retrofitting, but as a digital memoir for the cities. And moving to the automation drawing generation, just want to quick show how the sorry, I need to refer this to a little bit. So just want to show that our consulting team has set up the input slots for the suppliers. Later, they could come in and help us to complete the information modeling. Through this information model, we're able to communicate with the suppliers as well as the workers on site to telling them how we're gonna reroute this, for example, the fire system or the electrical system, but also telling them how much we need to purchase to ensure the smooth delivery and the purchase processes. And we're also pushing forward the IFC models into some construction planning tools to help the project team, project management to grasp on the minimum requirement for the facilities and equipment that they're going to use to complete the tasks. So just a little bit of animation, but however, the takeaway from this part is that it's really hard to set the standard industry standard for the procurement methodology. However, with the adequate openBIM informations and technologies, we're able to reduce the opportunity in cost and material waste to achieve sustainability. And augmented reality is another game changer in this project. The team transferred the collaboration and review task from verbal-oriented to graphical illustration, making things easier to grasp even for the stakeholders that with less industry knowledge, let's say. So you can see me sitting over here, checking on the QA, weekly QA, monitoring the weekly QA while I'm sitting in the office very comfortably. Well, this is just the management team are determined to pioneer in the technological advancement. So that's why we developed the in-house Revit to streamline their workflow. With just one click, we can push the IFC data back and forth from the Revit and Trimble. We can even uploading and downloading the data without the workforce supervision. Last but not least, sustainability. So all the data stored on the OpenCDE allows for analysis in multiple disciplines. especially for the lighting and facade design, were performed carefully with the aid of geographical information to ensure our newly installed facade has imposed minimum negative environmental impact to the surroundings. And these interoperable information optimize the design before the construction, also enhance the building circularities. And to close up the loop, we're hoping that this project became a starting point to connect and propagate to the point where all the existing building data could be included to fight this combat in the building sector. openBIM work with existing building is not something new, but it isn't ubiquitous in the existing renovation project in Hong Kong specifically. And combining this technology and methodology could give them a facelift in a relatively short planning and construction time. Don't forget the high ratio of the reusable building structure under the help of the technologies and the workflows vastly reduce the embedded carbon that could produce by the new used materials. Information-rich project models also allows the predictive AI to come in later in the asset management phases, telling us when and what to might need a little bit check on to help expand the lifespan of the buildings. Of course, we need some new designs in the building sector to push the creativity. However, I don't think the existing building, some of them, shouldn't be the victim of the new development. Especially they maintain the cultural value as well as they are the neighborhood, they have the unique neighborhood memories that I'm sure all the residents would appreciate. So the old proverb always leads to Rome. But as we're exploring the roads to the sustainable future, build up city resiliences, we need to find something that could maintain the cultural diversity as well. And lastly, thank you for sticking around, and I'm hoping to spot more highlights and insights in the later session. If you have any question, please scan the QR code or contact us through the emails, and we're willing to help. Thank you, everybody.
Thank you, Pan.
Thank you.
The next finalist in the construction for buildings category is Tecklenburg.
Good morning, dear ladies and gentlemen. Welcome to my presentation, Sustainable Interdisciplinary Planning and Construction of a District Police Authority in Bergheim in Germany as openBIM. So here you can see the pictures of the completed building in record time, 2.5 years. The first openBIM project in Germany, which was a police department. So we won the first place in a Europe-wide tender in order to realize this project. It was a BIM pilot project for all the stakeholders. I'm talking about 30 different planning companies, 40 contractors, and 1,200 project participants who for the first time did BIM in Germany. Hence, we had to set a benchmark project. After this project, all the police departments in Germany will be and must be done with BIM. So we set a benchmark in Germany for the first time. It's a DGNB Gold certified building, which means it is sustainable in planning, construction, and computer-aided facility management. We're talking about a property area of 21,000 square meters, a gross floor area of 17,000 square meters, and 430 police officers are already working here. We provided charging stations for electric vehicles and bicycle parking, a total investment volume of 66 million euros, and we achieved the best practice openBIM project from companies like Hilti, Nemetschek, and as well as University of Stuttgart. As it was a pilot project, how did we get into the change management? Because the first time we are doing BIM 2 years ago. So we established a BIM committee, which helped us in implementing BIM in this pilot project. So firstly, employer information requirements were created, software solutions and interfaces were defined, BIM execution plan was also planned as per the project progress. Tasks, competence, and responsibilities had to be redefined because people are doing this in the conventional method in Germany for 30 years, and they had to do a new role. We defined our BIM use cases and assigned them to a responsible department. We have 13 departments and 4 directors, so they all had to take their own roles. We set milestones and linked them to the deadlines, and also identified trainings and organized internal as well as external training. So coming to the key participant and stakeholders, the 30 different planning companies first time doing BIM had to be brought down under a specific organization. So firstly, we had BIM management, BIM overall coordination, BIM coordinators, and BIM parameter delivery, and also the BIM users. So the BIM users were the one who profited from the model parameters. We have the police, we have some banks, and also the technical people who are observing our project progress, the project managers. And we also have DGNB, which is sustainable chapter for Germany, which was gold certified for us. And we're talking about 1,200 planning people who, for the first time, learned BIM together with us and experimented with BIM here. So the first task was we created workshops and set our BIM targets. And these BIM targets had to be assigned to a specific department in order to take care of these BIM targets. So we had architecture, site management, calculation, marketing and sales, and also the BIM department. Talking about the openBIM information, we oriented our contracts and information requirements to ISO norms, DIN norms, VDI, which are also German standards, and international building openBIM standards, and also DGNB, which is for sustainability responsible. We have 9 different planning phases in Germany, and in each planning phase, we had a specific project goal, and it was always the information was transferred between the project participants with the help of IFC, BCF, and we also oriented to BSDD standards. We developed our own naming logic, and this naming logic or coding was in each and every construction material of the building. So we're talking about modeling guidelines for supreme discipline for us. We had 3 major models, that is the structural model, architectural model, and MEP, and a total of 120 different models responsible for sustainability, segmentation, landscaping, and also the road planning, because 430 people need to park their places here and also not disturbing the traffic from the outside. So very important BIM information is here. As it was an open tender, free choice of authoritating system led this project to be Open Big BIM. We're talking about 26 software solutions coming together for the first time in order to achieve our BIM targets. Hence, IFC interface helped in the data transfer, which was smooth and efficient. To achieve these project goals, which I showed you before, we had 21 Open BIM use cases and 5 add-ons, which I'm going to show you right now. A uniform naming logic and modeling guidelines developed as per Open BIM standards ensured high transparency and effective data transfer. So here you can see these 21 project BIM open cases was prioritized into 3 different segments, category 1, 2, and 3. And let me give an example. 1 was time scheduling, which was assigned to the construction management. Tendering and contracting, which was priority 2, was assigned to the calculation department. Priority 3 was sustainable material catalog, DGNB, and ESG, assigned to architecture and sustainability department. And then one of the add-on was earthquake analysis, which was structural and construction management. So till now, I was in change management, how we implemented BIM for the first time here. And now let me dive into the structural key outcomes. We're talking about model-based structural calculation as well as earthquake analysis, automated implementation of slit and openings with the help of Dynamo, formwork drawings, structural drawings, as well as reinforcement drawings were model-based. Here, in every BIM use case, I have an open BIM workflow for you guys to understand a bit better. I go through one of it. The architecture model comes from Allplan, and we transferred it with IFC, the information. And in Trimble Nova, the MEP model was designed. With the help of IFC transfer, we again implemented 30,000 openings in Dynamo, which was in the Revit model from the structural people. And in Tekla, we segmented it. And the earthquake analysis, as you can see here, also the structural analysis was done with Sophistic. And then later in CDE and OneDrive, Plot24 and DMS system, which was documented there. Coming to the key outcomes to MEP, we have detailed drawings for the MEP which came from the model, model-based calculations for heating, cooling, air supply, lighting, and also electrical was conducted. MEP models were merged into a coordination model and checked for geometric collisions. Issues were processed as BCF format via BIM Collab Cloud interface directly inside the operating systems. And this is also a very important BIM use case where we saved a lot of money and installation time. Optimization of MEP planning with the company Hilti. As you can see, it was before from the MEP planners as a single sole concept, mechanical, ventilation, electrical, and sprinkler were separated. But then with the help of IFC interface, we made a multi-sole concept where it was all combined. So anchor channels were already installed before concreting, as you can see here. Earthquake-proof anchoring system concept, because in Cologne, there is a mining area and we had to prove everything earthquake-free. And here, the planning and acceptance of the fire insulation was significantly simplified with the help of IFC interface, and hence giving us the positive outcomes, optimized cost and installation of time, and also prefabrication of the structure. So slit and openings, like I said, 30,000 openings were implemented with the help of our own Dynamo script, which was also checked in Solibri and BCF issues. I'm talking about effective implementation of slit and openings. All the walls, all the slabs were prefabricated, and all the openings were already inside. We're talking about 2,000 kilometers of data cable and also electric cables, which are already prefabricated and also delivered just in time for the site. Planning changes were easier and less error-prone, transparent and efficient coordination between the planners, a rationalization and quality improvement in cutout opening planning, and hence giving us the positive outcome in this workflow, automated workflows, and better plausibility checks. Coming to the next important segment, clash detection. A coordinated planning with quality assurance was achieved, early detection of issues, visual representation and organized documentation, and cost reduction by avoiding construction delays, and hence giving us the positive outcome. 7,800 issues were resolved even before the construction start. I'm talking about 60,000 euro fine delay per day if we didn't submit the building in time. And hence we submitted the building in time, and thank God, this workflow really helped us a lot. We're talking also about 4D and for scheduling and cost controlling. Effective quantity takeoff was possible. Accurate cost estimation and cost calculation. Model-based tendering and contracting. Targeted and actual comparison of deadlines and costs were possible. So hence giving us the positive outcome here, costs and deadlines were all time under control with 4D and 5D simulations. Sustainability with BIM is a very important aspect also in Germany. Like I told you, this building is DGNB Gold certified. The documentation of the Gold certification was automatically created from the model as it greatly simplified its process. Here you can see an example of sustainable evaluation with insulation. We had 26 different types of insulation, and these evaluations were also carried out by ceilings, slabs, facade, windows, and other 40 different building material types. Hence, achieving the circular economy using DGNB certified building material as a cycle for further use is ensured, as sustainable parameters were stored in the IFC model. Sustainable circularity passport was also achieved here in this process. All building components were selected as per the DGNB material catalog with the help of IFC interface, and hence giving us the positive outcome, reducing miscalculation, improved life cycle assessment, low carbon footprint, and a climate-friendly building. Prefabrication of the structure. It's a very important case for us because we are a 6th generation construction company. We are building since 1878. But we implemented BIM for the first time 2 years ago. What I'm talking about is efficient work cycles, reduction of setup time, optimal utilization of equipment, and just-in-time delivery for the construction. As you can see here, the structural model was segmented, and we also had a QR code so that we can see if the prefabricated wall is under construction, if it's under delivery, or is it still in production in the factory. Efficient construction management through model-based invoicing and cost management was achieved. Quality management during execution helped detecting errors in advance to make the right decisions. And giving us the positive outcome, openBIM was instrumental in saving costs, resources, and time. Identification of increased costs were possible, and optimization potentials were increased. Lean management with BIM, very important aspect for site management. With the help of IFC interface, construction progress was recorded, enabling regular comparison between targeted and actual time schedules. Digital documentation of weather, equipment, and labor working hours was also possible. Lean management of the site with tucked planning in CDE for smooth workflow of the construction site, and hence giving us the positive outcome in this workflow. Automated billing processes were achieved, which were digital, real-time tracking, and optimized site logistics. Here you can see in the CDE, the structural model, also with weather documentation, 3 times a day, the number of equipments, and also with pictures. So we are always in time and in track. So visualization supported and simplified the interior design process. Virtual reality, augmented reality gave the police officers and the public officials a tour of the future building. We're talking, it's the senior police director and the minister of NFA were really thrilled to see these BIM workflows in the site meetings every now and then. Positive outcomes for material selection process was simplified. As you can see, the openBIM workflow is still there in every aspect what I've shown. Defect management is also a very important task for us. So we're talking about 3-dimensional documentation of defects with the help of IFC interface. We had around 52,000 tickets which were documented and which were closed in time. Issue management directly to subcontractors through ticketing system. Like I said before, fire insulation was missing, and after the fire insulation was created, we closed the ticket. Positive outcome here was smooth transfer to the warranty department. Also very important, computer-aided facility management. We had 150 different types of parameters which was implemented with our own Dynamo script in the model, and hence creating a LOD 500 model. So I'm talking about different types of simulations for the police and the state, like cleaning concept, fire drill simulation, and also evacuation, which was created with a click of a button. So in conclusion, guys, despite Corona pandemic, supply chain issues, and increased prices, all our deadlines and costs were under control. Thanks to higher data quality and minimal loss of information, we could convince the public sector the benefits of openBIM for the first time in Germany. 2 years ago, BIM was for us new territory, but now we are proud of our progress. Thank you very much and have a nice day.
Thank you. And if you can stay there, and I can see, Han, you're making your way back to the stage with me. Okay, again, thank you to both presenters there, and we'll go to a Q&A session. I can see Peter reaching for the mic first. Please go ahead.
Okay, I'll repeat.
Yes.
Which of the 21 openBIM use cases and workflows actually gave the largest value to the project?
Yes.
And to the project as a pilot project?
Yes.
It's 4 questions in one.
Okay, there were 2 actually it was 25. We had 19 use cases plus 24 plus 5 add-ons. The 3 most important work cases which really helped us is, the first one is clash detections, because like I told you, 7,800 issues were resolved beforehand, and hence we could deliver the project in time, because we had a 60,000 euro per day fine if we didn't deliver the project, because there were several banks involved and also the police department. And we delivered it in time. If we had delivered it maybe 1 month later, and we could not cope up with the company. So that's very important. Second thing was sustainability, because we have a DGNB Gold standards. We can know where our materials is going to be used in the next 20 years, like metal facade or any other type of material. So that was very important to get this certification. And the last one is also lean segment, because we could organize our site logistics and also the delivery, because the whole of structural system was prefabricated, also the metal facade and also the suspended ceilings and the cardboard walls. They were all prefabricated, and with the QR code tracking system, we could get it in time. So lean management also, I would put it in priority 3. But all the openBIM use cases, what we used, were important, and that's the reason why we also did it, you know. Thank you.
Okay, my question is connected with the previous one. I did not see resource planning in your in these bullets. So my question is, if you are using BIM software for resource planning, or you are using, for example, Microsoft Project or some other software, because this is really important thing when we are talking about using of BIM and in construction phase.
Yeah, actually there was a video which was implemented, and the video did not play for some reason. But we had 4D and 5D simulations which were done in RibEye2. That means we got our planning project plan from the external architects in MS Project, and with our own Arbeitsvorbereiter, it's called in German, the classic person who plans the construction of the site. So he made it again the right tact planning with also lean management, and this new time schedule was implemented in RibEye2, synchronized with the model, and we did 4D and 5D simulations. So we had costs and also time schedule under tracking.
And the information about resources, for example, how much workers, machinery, and so on.
Also.
How did you also in Microsoft Project?
Yeah, from Microsoft Project, we got the basic time planning from the architects, and we have it's a specific type of profession under the construction department. It's called Arbeitsvorbereitung, and this person has experience how much time is required for a 20-meter long wall to be built in this scenario, in this weather, and based on that, we calculated even on the seasons and put this in the software called RibEye2. So we had number of equipments, number of cranes, and also crane rotation for the site logistics. And there was also the material resources required, because we had 40 different type of material resources, and they had to be booked in advance because they're DGNB certified materials. We cannot get some materials directly in Germany. Some materials like a trafo station for electric had 2 years waiting period. So we had to plan all this before, order it, so that we know in 2 years it's going to come in the site. So yeah, I'm sorry, the video did not work because I think there's a difference between Mac and Windows system, but I can show you it later. Yeah.
Thank you again. Congratulations to you both. Thank you for your presentations. My question is for Pan and the hotel refurbishment. A lot of the use cases seems to be very geometry based. Do you have any data driven use cases in the project?
Thank you. Sorry. First of all, I would like to declare that because our construction is still undergoes, it's not entering any like complete projects is still not complete. So most of them were maneuvered with was the geometry of the buildings, but we do have to, have some inputs for the E&M components for later asset management uses. We have compiled the equipment information from the suppliers and from the manufacturer, the side of the manufacturing, to put them into for now it's just in a simple Excel form, but I'm sure the Excel form could be translated into the COBie in the later stages, and all of them are stored in our CDEs, which could be shared and downloaded by the later on the management, the asset management groups. Thank you.
Thank you.
I would like to ask a question to the same project. You mentioned that you are using IFC in the integration to ArcGIS regarding the sustainability. What was the benefit in that context of using IFC compared to the alternatives?
Okay, that's a really good question. I need to give me a little bit of time to think about it. Comparing to the benefits of comparing to using the IFCs with the simpler geometries, because IFC you could input is not just the geometry of the buildings, but you can input some other attributes such as the reflection rates of the windows, or how the airflow is going to go in that particular area, and all of that information was stored in this huge pack of databases, and from that, for example, the E&M designer could take that information and run their analysis and to help design a let's say more environmental friendly design to the buildings. But if you're just using models with only the geometry information in it. How I honestly, I don't know how it works, but I feel like this is going to be a hard work for them to extract all the informations once again by doing the hand calculation, maybe measuring on the softwares. So yes, I see acting as this huge bundle of data that helps smooth the calculation and design process, which eventually help us achieve the sustainability of the buildings. Thank you.
Time for what? Time for two more questions. If there are any. If not, it's no problem. We don't have to force them out.
I have one project more for the same project.
Yeah.
In one of your first slides, you mentioned openBIM processes, and I would like you to express which of the processes during your project you actually have seen giving most benefits.
Okay, I have a lot to say on this part because me and the team responsible for the 4D and 5D planning. So with the IFC model put into these planning tools, we can have the visualization, you know, the little animation of how the components gonna move to the side and how they're gonna assemble using what type of equipment. And I would say that with that early planning, and we helped the management team to spot the possible obstacles that might occur during the delivery and assembly processes. This not only saving them a lot of money as well as a lot of time. So I would say that the application of 5D and 4D of the openBIM side is, I would say, is the benefits the most for the stakeholders would benefit the most. Well, for me, I benefited from playing around with applications, so it's quite fun. Thank you.
All right, we are at time there with the Q&A. Thank you both again very much. Thank you to the jury for their questions. And I will again hand over to Claire to introduce the third and final category that we will have in this first morning session. Thank you.
So yes, the final category is Handover, and our first finalist is China Academy of Railway Sciences together with China Railway First Survey.
Good morning, everyone. I'm very glad to stand here and to have this opportunity. And let me briefly introduce myself. You can call me Matthew, and I come from the China Railway First Survey and the Design Institute group. And the scope of my studying is railway communication, signal, and information technology. And also today, I'm going to introduce to you this topic, multi-domain openBIM digital engineering certification and handover for JiuQuan-Ejina Railway. And actually, I really wanted to spend a whole day to introduce it to all of you because it's really a very complex project and lasts at least 2 years. And so many works we have done. Unfortunately, I only have 15 minutes or 14. Okay. So I got the plan B. Plan B, that introduction involves 3 parts here. And also this PowerPoint is very long, so I will be briefly to introduce. The first is the overview of the project here. And as you can see, this is a railway project in China. And also this whole railway combines 2 cities. One is a vital satellite launch center in China named JiuQuan. And another city is a very popular tourist city with popular forest and named Ejina. And also this railway is part of the Belt and Road Initiative. Okay, our pilot project is based on this railway. And actually, everyone knows that BIM technology has been widely used in many industries, especially in China, in railway industry, and also we like the equipment factory, design institute, and construction enterprise. They all use the BIM technology to create digital assets already. However, these digital assets are lacking of we call it uniform standard. And so they are really hard to be delivered and be used from the construction stage to the operation and management stage. So we do this research on digital assets validation and certification and use this technology in our pilot project already. And here, before the next, I would like to introduce to you a one-word full electric in China railway industry. And we created this word. It contains the railway communication, signal, electrical power, and chemistry, and other fields. Because I will use this word later, okay? And here you can see this is the core team leaders, but there are more people. So we just have limited, and they are very professional and technical staffs from the many parties, like the owner, certifier, consultant, validator, and certified parties. So many parties involved in our pilot project. So this is a very huge project. And at this summit, as I participate, and they just mentioned many times that the standard is a core element, right? So also the standard is the core element in our pilot project, and we based on the ISO 19650 series standards, FC, and other openBIM standards, and also the China Railway BIM Alliance standards. Okay, here is an overview of the key openBIM information here, and from this cycle we can clearly see that the validation and certification between the construction and O&M period, and the blue just shows we have a lot of work has been done to guarantee the digital assets that can be delivered from the construction period to the O&M period and can be used in O&M period. So also we have made a lot of achievements on the right side. Okay, let's move on to the part 2, openBIM outcomes. Actually, there are 4 main outcomes in our pilot project. Okay, one is we establish a digital assets validation and certification system based on openBIM. And second, we digitize a series of standards already and to make them like a dictionary database. And also we developed, I think it's very new, automatically detect the digital assets validation platform based on FC. And fourth, we develop digital assets handover and application based on COBie standard and VR AI technology. Okay, before the details, I'd like to show this software ecosystem map, because this map can clearly show what our pilot project do. Here has 3 stages, right? Construction, handover, and operation and maintenance. Firstly, in construction stage, we use FC format as a transmission format and integrate like the GC information or other information together to build a full scene digital asset. And then in the handover stage, secondly, we digitize a series of standards as the basic, and then we develop the laboratory and on-site validation. These 2 validations that can automatically detect the digital assets from the construction stage. And after that whole process finished, we also developed the full electricity operation and maintenance management system. So full electricity, I mentioned before. And then we just achieved to deliver the digital assets from construction to the operation and maintenance. Because this system, full electricity system, we use it as the digital assets, like the basic core elements here, and to help us to develop many functions that can help the operations personnel to do their work and with these digital assets. Okay, in detail, the first outcome, validation and certification system. As you can see here, we just meet the information requirements of ISO 19650, and there are 6 items here from OIR to AIM, and we all meet them already. And here is a flow chart of the information management, and from the start and to end, 8 stages, right? And we all confirming to ISO 19650, and especially for stage 6 and stage 7, we do some localization integration here. Okay, this slide shows the CDE, right? But here, I just wanted to focus on the shared and published. We just developed our validation platform between the shared and the published. And this can guarantee the digital assets from the shared that can be delivered to published. And also, this is all information archived there. Okay, besides, based on the CRBIM standards, we in our pilot project, we also created the full validation standards also, and these standards directly support our validation platform. Here is a flowchart of the certification system. Briefly, it's constant preparation, validation, certification, and like training, and all brings many benefits just showed over there. Okay, and this use case has been uploaded to the website. If you are interested in it, please feel free to visit. Okay, and we still conduct openBIM concept training already. And in China, in China's railway industry, over 122 railway employees had passed the training and the exam and get an evaluation certification already. And also, there are currently 2 validation institutions with the qualification of railway FC model certification and validation already. Okay, let's move on to the second outcome. In this part, we just digitize a series of standards. And firstly, we organize standards as an easy entry. And secondly, we develop the standard management software, and it is authorized by NCA. And also, when we finish, we just digitize a series of standards, and they are like the core elements and basic to support us to develop the automatically detect validation platform. Okay, here are the hundreds of entries that we have extended in our full standards like FC, IDM, FD. And also, you can see that there are so many entries that we have digitized and to make our own database here for the dictionary. Yeah. And the third outcome, validation and certification based on FC. In this part that we just use the FC format, we can transfer different format into the FC format. And then we just use the digitized standard to support our application and our validation platform. Okay, this is the architecture of our entire validation platform, and it consists of the data storage, technical service, basic service, and gateway service. Okay, in this map, I just show that we just transfer the different format into the FC format, and then we support to extract the information from the FC format. And with our validation platform, it can automatically detect this information and finally give us the results. Okay, another use case uploaded also. If you are interested, please visit. Okay, and this is a validation process. And also, when we just digitize the series of standards and also extend some standards already and establish a whole process with our validation, and our validation platform has a laboratory and on-site. Okay, and depending on these 2 validation platforms, we can detect the digital assets from 4 dimensions. And 4 dimensions are showed here: category, geometry, space, and attribute. And also, we found that these 4 dimensions that can good to represent the requirements of the operational personnel. Okay, and here's our pilot project. We have already done the full digital engineering and full digital digitized equipment, and these are all certificated and has been approved by Chinese government. And here's the results that we get. We obtain in our pilot project, like the certification and the properties and reports. So, okay, the last outcome, handover and application. I think this is a significant one, because in this map we just when the owner initiate a commission, and the certifier and the validation party, they will help the owner to detect the digital assets from the certified party. And when this whole process finished, right, the digital assets, they are validated and certified is okay. Then the digital assets from the certified party will be accepted by owner. Okay, as a delivery of digital assets, there are not only digital model, as we all think that delivered, but also 56 digital engineering model drawings and more than 80,000 pieces of digital asset information delivered. Because in the pilot project, we just found that handover digital assets, this really faces the operations personnel. So we spend a lot of effort and time with them to get the requirements. And then we finally find the suitable form of digital assets. And this can really help them to get the information they want more efficiently and accurate than traditional way. Also, this is another part of our key, because here we just developed another system we called for electricity operation and maintenance management system. And why we created this system in our Handover, because that's very easy. We need to develop this application to prove that the digital side, the digital assets that is validated and certified is okay and can be used in maintenance and operation field. And also we do many functions here to help the operations personnel to get to maintain their device equipment, and also integrate the BIM, the GIS information to do some more functions. And also based on COBE standard, we just do this, show the cable related data that can be easy to view and acquire, and roaming and positioning. And also based on COBE, we just do more research and to make the static data and the dynamic data just related to the digital equipment. And also we achieved the data visualization. And thanks to the AR/VR technology, we built our on-site validation platform. And also this function we found that is very popular to the operations personnel, and they can use them to find the hidden engineering information easily. Okay, finally, let's summarize this pilot project because we have only 1 minute. And here's the data summaries. And you can see in this pilot project, we really did a lot of work here and so much results that showed on this slide. And also our pilot project based on openBIM really reduced the cost and the time. And here is the specific data. Of course, this is the application proofs, and this application proofs from all parties that are involved in our pilot project. Okay, finally, in future, we hope that the BSI will have more pilot projects. Maybe we can collaborate and in the China's railway industry, and we still to continue to improve some of the function and tools, and to train more people in the railway field, and also to promote the application of BSDD. Okay, so that's all what my presentation, and thank you for your listening.
Thank you, Qiang. So our final finalist in this category, okay, is from Enel Green Power. Unfortunately, Lucrezia can't be with us in person today, but she should be joining online right now.
Hi, everybody.
Are you there, Lucrezia?
I'm so sad to not hear.
Okay, if you can start sharing your slides, brilliant. It's all yours.
Okay, thank you. Hi, I'm Lucrezia Bartoli, and I'm working from Enel Green Power. Enel Green Power is a world leader in renewable energy sector that has to manage assets under construction and in operation in 21 countries worldwide, reaching and installed a renewable capacity of over 59 gigawatts. The project is part of the process of implementing the BIM methodology in Enel Green Power during the entire life cycle of a renewable energy plant, solar, wind, storage, and including substation at a level global. The project consists of a new digital solution to improve and optimize the process of handover to operation and maintenance. The system is an IT infrastructure that supports and integrates the data transfer process based on the BIM methodology, and especially on the interoperability of tools thanks to the use of the open format AFC. The system consists of several subsystems, including the IUP, that is a document management system, that is a document repository that also serves an approval workflow for project elaboration, internally development within Enel and OpenText, and AVEVA ISMM, that is a platform open to navigation of the interoperable IFC models that allows you to query uploaded BIM models, read electrical tags, and transcode them in functional location. And also the SAP with the ERP and IAN modules. That is a system that operation and maintenance, or O&M, uses to manage the VBS of the technical size and organize its maintenance plans. The first step in the process is to export the BIM models from native authoring tools, such as Revit or Civil 3D, into IFC4. And secondly, the IFC file are uploaded by the supplier in IUP. And after being validated by Enel team, models with the B-model open format metadata are transferred to AVEVA system. This system consists of a dedicated gateway module that processes the IFC file and turns in the IFCs into an XML format that containing structure information. AVEVA system uses a web interface and a database to share the data extracted for the IFC file. The object identified by a tag having certain set of properties are appropriately organized according to a transcodic logic related to an international guidelines to facilitate the management of functional location and equipment object. The transcodic plant is sent through an automatic integration from AVEVA and the module of Sapine. Previously, to this innovation solution, the transcoding task was performed manually by O&M specialists, which result in a considerable expenditure of hours and probably of errors. So the data set is managed through a customized tool that allows to synchronize all corporate systems using a data breakdown structure. In fact, this code identifies every single requirement information and simplifies the process of searching the analysis data, moving from file-based CDE, common data environment, to a truly database CDE. This cutting-edge workflow brings the value to the entire value chain of the company. The key outcomes are it ensures security and quality by control and validation data about IFP, liability, risk, and contracts, and the authenticity of users. Also improves data governance thanks to the definition of new parameters to insert within the models all the data necessary for the development and maintenance of the project, and enhance collaboration within the stakeholders through the development of a unique source for all phases in Enel process. For the in economic benefit, it saves a significant amount of money and reduces time for our employees, together with the reduction of iterative action that leads to human errors. Finally, the data breakdown structure increases the efficiency during routine and extraordinary maintenance of the plant. It guarantees an high quality of the data plant registry and decreases the time to solve the problem. Enel Green Power aims at applying BIM technology on 3.3 gigawatt out of 4.2 gigawatt of additional capacity. Therefore, this innovation solution will automatize the handover to operation and maintenance through the use of the interoperability format AFC. And we are proud to announce a potential time saving approximately 90%, which correspond to thousands of full time of equivalent. This is the team, IT team and digital team that work on this implementation. And thanks for your attention. We are available for any further clarification. Please contact me and to address dedicated question. Thanks all.
Okay, thank you both. If I could ask the first presenter to please rejoin me on the stage. And Lucrezia, are you still with us?
Yeah.
Okay, brilliant. So, to our elite jury, yeah. I will open the floor. Who would like to ask the first question?
I have a question to the last project, the last solution. I would like to ask, did you see any alternative to use IFC4?
Yeah, we initially using the IFC to multiply 3 IFC format, but now we use IFC4 for the geolocalization for the model, for the BIM models.
Okay, thank you. Casey or Sonia?
I have question for the first team. So can you explain which technology was used to create as-built model? How you capture data and how this was created?
Yes, and actually we just use many software and technical in our pilot project.
It is working just a bit closer.
Okay, yeah, and also we use Bentley and also the Revit, and also because in our pilot project we the construction they just construct these digital assets with using the mechanization Bentley, and also but actually we have our own cooperator to use some technique to extract the information that come from that model and to transfer them to the FC model, and we have another based on another technique to build a whole validation platform. Yeah.
And so the key open standard for the graphical part is also IFC for handover.
Yes, because FC, this format, I think it's very popular and it's really useful. Yeah, because every software they use their own format, and also in this we have the factory equipment, and as we can know some SolidWorks and probably some sort of factory to use that to produce a model, and so we need to also to transfer them to the FC model, and also this can be used and can be delivered.
Final congratulations to these two projects from me. Well done for getting here, and thank you for your presentations. My question is for the Enel projects. Lucrezia, it's a very slick process for moving data from various different platforms into your operational platform. Have you thought about any particular uses for open data IFC within that operational phase for other use cases coming down the line?
Well, I am here representing Enel Green Power business unit. So I took part of the initiative to define the need and ally with the many other IT and technical colleagues, test and adopt this solution at a large scale. So unfortunately, I cannot address your question, but you can contact me by mail, and we will arrange a dedicated meeting to clarify the doubt. Sorry.
Okay, thank you.
I have a question regarding the validation and certification solution. In the use of your solution, have you experienced two things? A change in what you are actually validating, the maturity of what you are receiving and should author, and the other thing is, have you changed your validation during the period where you have been using it? Have your maturity changed?
Actually, the validation, they also have a whole process, right? The whole process. And but here we just focus on the handover, right? So to deliver the digital asset from construction to the maintenance, and to make sure to guarantee these digital assets can be used in the operation and maintenance. So our process is just focus on the delivery at that stage, and also we do some sorts of things like to contact with the factory and also the design and the construction, and also we have a series of processes that we need to follow, and then and that's the key point as I mentioned before, and at the delivery stage, and we just use our validation platform to detect these digital assets. Yeah.
I have one more question, probably a clarification for the validation discussion. Is the system checking whether there is data present or whether the data is correct, or both?
Yeah, that's a good question. Because in our pilot project, we always discuss what kind of standard or things we need to get. And we found that because our purpose here is to through this pilot project to make the digital asset can be used, and so we cannot like the consultant to make sure the digital asset made from the construction or design period that's very correct, right? Because based on the many documents, right, and the design standard, and they may have the several or different ways to design this modeling. So but we are here. We are not focused on that. We are not to judge this design document is correct or not, but we are judge it if the government or if you're like the design institute or construction enterprise, and if you decide this digital asset is correct, okay, let us to detect to see it contains the elements that we have, because the operations personnel they need that elements. And if you don't have it, and this only the modeling that cannot be used, okay, this cannot pass our validation platform.
All right, thank you. Any other questions? 1, 2, 3 shakes of the head. I think we can call it a day there then, a few minutes early. That's great, thank you. Thank you again.
Okay, thank you.
Thank you.
Okay, so that is the end of this session. We've heard from 6 presenters there, 6 projects. I think we can agree, all very good projects. 3 categories. We will now break out, myself with the elite jury. Thank you again for your time in helping us with this. We will go now and make our final decisions in secrecy and in confidence, and we will meet here again this evening for the announcements of the winners. So thank you. We'll bring this session to a close and see you for the next group of presentations. Goodbye, everyone.